Hey guys, what's up? Eddie Owl here with KissAnalog.com and a big old box on my bench. You know, it's a box in a box. They ship things pretty well. This is a new vendor. They reached out, asked me if I want to review power supply. I'm like, you bet. So, lots of packaging. Let me pull the box out of the box. Alright, hey, it's been a while since I've done a review. I think since the holidays. I was doing a bunch of them for holidays, just to see if I could help out people that wanted to get things for the holidays. And then I took a break on that for a while. Wow, look at this. First thing I see is the manual with photographs. It's all black and white, but looks like it's well illustrated. I'll show a close-up of that. Kind of some jumpers, banana to alligator. Alright, we'll see what that's for. But yeah, so this is Matrix technology. And, you know, they claim that they make some high-quality equipment, so let's see. Alright, we got a second set of banana to alligator. Oh, sorry, 3 sets. Wow, so 3 sets of these, a power cord, a manual, and some foam. You never know where you're going to need some good foam, you know. Alright, so this is made for the US, IEC, it's switched over to 110. It's so funny that the 110 is just stuck, because it's actually 120. And then RS-232 USB, RS-485 expansion ports. So obviously I don't have these add-ons. And then here is the import for the fans. What I can see is some vents right here. Look, very interesting. I want to open up this box because that is a very interesting structure. Now, one thing I can tell you is I have to look up the weight, but this guy is pretty heavy. It's a triple power supply, just like that one or this one. Well, this one's all programmable, and it's more like this one up here. Now, this GWN stick up here, it is, they make this Tektronix, or they made it. I don't know if they still make them, because, yeah, I don't know the age on this. But anyway, they make some nice power supplies. This is 3 amps, 30 volts, you know, two sides, and then a 5-volt fixed 3 amps. Whoop. Oh, there's the big old, that guy's got some weight to it. Look at that big old silica bag. So, that's nice. Keep it dry. Matrix MPS-3005H-3, in parentheses, 30 volt, 5 amp, 2 channel, 5 volt, 3 amp. So this one has a little more oomph than that one. 30 volt, 3 amp. So that's 90 watts, and then another 15 watts. So 180 and then 15, not quite 200 watts, right? So this one is 30 times 5. That's pretty nice. That's 300 watts just between the plus minus rails. So that's, I think, much better for audio testing, for instance, because you can go up to 30 volts. You got plenty of current, I think. And then this guy is variable for the 5 volt output. So I'm kind of curious if it's, I'm assuming it's 0 to 5, 3 amps. So that is pretty nice. And these binding posts, I'll bring in, have you take a look at these. They look nice. So, this one up here has switches for volt amps. And you know what? Maybe I'll set them on top of each other and do a little comparison. You can still find that one for sale, especially on eBay. That's where I bought that one. I bought both those off eBay. I started off with this nice programmable one, but this is only 2.5 amps, 20 volts. That was really limiting. So, yeah, really limiting. Nice for op-amp testing, that kind of stuff. But otherwise, you know, not usable for a lot of things. Programmable, really nice, but really sophisticated, but no power. This one has more power. It's more manual controls like this. You can series parallel these two. You know, these are tracking power supplies, meaning you can use one as a master and they follow each other. That way you can use a plus and minus. Now up here you can see the plus minus terminals ground, plus minus terminals ground, and plus and minus. This one has plus and minus, one ground. That's all you really need. You don't really need to be connecting a ground to each one. The other thing, here I'm really interested, and I have a feeling it's not going to work, because I can just by... Alright guys, I'm really interested. I have a feeling it's not going to work. It doesn't look like the spacing's right, but these little plugs are really nice to use. Whoa! They look too close, but it actually fits. Wow, visually, I thought those were just too close. That is attention to detail. I just love it when they do this, so you can use these plugs. You can buy these kind of banana plugs that you can put your own wires in them and put your own gauge and then screw them in. This one I use a lot for multimeters. I use it for power supplies too when I can, but a lot of times, let me see. Look at that. Those fit. Now see up here it doesn't because they put the ground in the middle. They just weren't thinking. Over here the ground's in the middle. Even the Tektronix has the plus and minus next to each other. So Tektronix, even though they made this power supply for Tech, they must not understood why Tektronix said put plus minus ground, plus minus plus minus. So this Tektronix is set up like this, one ground. They must have thought, hey, we're going to be nicer. We're going to put a ground in the middle. Like Kai Weitz must have been thinking the same thing. Hey, let's do that. That's a nice thing to do. No, it's not. It's nicer to put plus and minus next to each other, spaced at this distance, because at some point this becomes a standard. I've got this little AC meter, I don't know if you can tell, and look, they fit that one. So see, that's a standard width, and everything has a plus and minus, like these multimeters. They should be spaced that distance. That's why. And let's see, I'm looking up here. Oh, look at this IT Tech. Check this out. I don't know if you can see that from there, but that fits. And then the ground's off to the side. That's the way it should be, guys. Over here, the HPs plus and minus together, just like the Xantrex. So, way to go, Matrix. Nice job. Now again, like I said, I'm going to show you a close-up of this, but just looking at this, I'm really impressed. They have it says long push. So this thing is, these pots are not analog like these. So these pots are actually digital pots. You know, they're encoders, so they send out a digital signal, and the microprocessor, yeah, see there's no stop. They just spin around. So these guys are encoders. So there is, even though it looks like this one has stop, okay? It's an analog pot there. This one's programmable. This one has the look of this analog one up here, but these guys are actually digitally controlled. I don't know if that's better or not. They have long push, so there is some kind of programmability. So, okay, overvoltage protection, you push it in for a long time, you can set the OVP. Push this in, long push, you can set the overcurrent. So we'll see how that works. Okay, really cool thing. Again, when you come over here to look, you can push on and off channel 1, on and off channel 2. This one has series, parallel, that kind of stuff, but there's no on and off. There's a power button, but once you crank up the voltage and set it, it's there at the output. I wish there was an off position, like when you pulled them in one position. I wish they did turn off so you could, like this, turn on this. Oh, okay, now I want to turn on this one. Oh, okay. And they're just digital momentary buttons, so, you know, it's like on, off kind of thing. Same thing with this button. This button's for the series parallel. So over here you have these two switches. You put them in some kind of combination for series parallel. This one has, you just toggle through the three different settings, the independent, series, or parallel, where that one has two buttons, and you have this map on the front that tells you what configuration to put it in. So already I like this, and also has amps, volts, amps, volts. Over here I'll put one side on amps, one side on volts, so that way I can, if I'm using it as a plus minus power supply, or if I'm using them in parallel, in either case I can have one meter show me current. Now in parallel it works great, current, voltage, because parallel they're both the same voltage, same current. In series, hopefully, because they're tracking supplies, hopefully the load's pulling the same current on plus and minus, but it might not be, right? A lot of times it's not. So on that one, sometimes I have to switch over to make sure both sides are carrying the same current. But with this one, I got current, voltage, current, voltage. On these, you got current, voltage. On those, you have current, voltage, and watts. I really like that. But I guess with all the digits, 4 digits I can see, looks like 4 full digits for each one. It'd been kind of cool if there's a button in the middle that you could switch to watts or something. That would be kind of cool. But so channel 1 says slave, so channel 2 is the master. So you would use these knobs here. I guess the right hand, maybe that's why they did it that way. Put channel 2 because the right hand controls as the master. Maybe that's why they did it. So we're going to plug this in. Well, actually, we're going to open it up. I really want to see that fan structure. So let's open this thing up, take a look inside. Like I say, oh, and by the way, it has a carry handle on top. So a lot of people like carry handles, right? And it's recessed. This, again, I've said it 1,000 times, but I'll bring the camera over so you can see it close up. But yeah, I just wanted to kind of talk through some of this stuff. It looks like only 2 screws on each side. They'll hold it down so it'll be easy to take off. So we're going to go ahead and do that. And maybe we have to take 2 screws on top with the handle. I don't know. But yeah. Okay, the power, by the way, it's a mechanical switch, which we like. So when you turn it on and off, it physically turns it on and off. There's, like the Siglet scope back here. It's a soft switch, so when I power it off, it's not really off, it's just asleep. So I like to have it physically turned off. One of the advantages of having a mechanical switch is that if there is a surge, some kind of problem with the power, well, I'm mechanically disconnected from the power. So if I walk away from a lab, go to work, come back, after a weekend or something, then I can push it in and it's going to work, because maybe if there's a surge or lightning, nothing got through because I had my switch off. So that's a line of protection that I like. And if there is a problem with those sleep things, sometimes you have a switch in the back and then switch, that's okay because you can reach in the back and turn it off. But like in the case of the Siglet, it's just on. So the only advantage to that is that when you power it on, it comes up quick. Although, when I'm sitting here getting ready to do this video, and I want to turn on my things, like I usually turn on my meters, right? So you guys can see my meters. Anyway, when I turn on everything, they all come up about the same speed, even though that guy is asleep. It still takes about the same amount of time as both of these scopes. So they're all fast enough that I'm not going to complain. I'm not one of those people that things have to turn on immediately. Although when I turn on a multimeter, it's nice that it just powers up right away like that. See, right there, boom. Instead of like my Fluke 289 up there. That thing's my least favorite meter of all my meters. It's big, expensive, and it's slow. And it goes through batteries like crazy. Anyway, sidetrack. Side note. Hey, we're doing equipment reviews, right? So, all right. All right. I'll look at the manual, tell you what the weight of that is. Maybe I'll undo my stack here and put the GW next to it. You can tell it's the same form factor as these two. It's just a thing. See all these things? There's a form factor, whatever they call that. Yeah. Alright guys, let's bring the camera over. Alright, so that is the power supply. The top of it anyway. Here's the manual that comes with it. Pretty cool they actually give you a printed manual. I guess all the different models here. Here's one with the options. So yeah, looks like it's a pretty nice manual. So you can set the settings so that it powers up in a certain way. That's pretty cool. So there's some kind of programmability. Alright, so that's pretty cool. Anyway, set that aside. And let me just show you what it looks like. It'll look better when we have power on it, right? There's the back. And there's the bottom. So by the way, it does have some nice feet on it. And look at that big old thing. Let's find out what that's holding down. Alright, so let's open it up. Alright, so it took 4 screws and the 2 screws holding the handle down. Okay. It's a piece of metal that runs through this rubber to keep it strong. And voila! There we go. Now, just in case you're curious, the inside's just unpainted. It looks like aluminum, or feels like it, maybe. And that stud was holding this gigantic toroid. That is pretty amazing. That is one heck of a toroid. That's large. Got several wires coming off this side. Bunch of wires coming off here. Wow. Yeah, I'm so impressed I stopped looking at this. But look at this heat sink. That's what I was looking at in here. You can see the vents, maybe. And all I could see is fins. So that thing is just a gigantic heat sink with the fan on it. So that's pretty impressive. Then we have a bridge rectifier here. And a couple devices there, which probably a couple transistors. And there's a thermistor mounted right to the heatsink right there. Alright, so maybe you can see it better there. Hopefully it's focused. But yeah, pretty cool. And these look like 3 relays in here. And a bunch of big old resistors. And there's a couple of shunt resistors there. And another big resistor. Looks pretty high quality, nice board. Here's a chassis ground come to the board there, it looks like. Yellow and green wire. I see it coming all the way across here. Let's go look over here. That goes up that way towards the front panel. Wow, look at that. So that part of the panel, you can see some caps here, some film caps down here, those orange things. 3 trim pots here in the corner. A lot of surface mount components. There's a crystal oscillator there. There's a beeper right there. Here's a crystal oscillator and there's a buzzer. Then let's spin over to this other side. Okay, there's a view of the whole front panel of the board. Man, it takes the full size of the front panel. There's a little cutout where the switch is. Other than that, it's, yeah, pretty cool. Lots of circuits there. It looks like to me it looks like it's done very nicely. Here, let's spin it around. Let's look at the other side. One thing I want to point out is you can see the power switch up here, and they've used a heat shrink to cover it, so cover the electrical connections and to kind of hold them in there. I mean, yeah, I think it's just mostly for protection, but that's pretty nice. There's some more relays down here on the board down there. Okay, so we saw this corner of the board, right? And as I tip it up, you'll see this corner looks a lot. Here, let me spin it around this way. Okay, there we go. Same kind of thing, a bunch of relays and some more resistors, some more shunt resistors down here. If you can see those shunts. Maybe you can see the little shunts down in there. Those little wires. And another big electrolytic, another rectifier. So this must be for the other channel. And then, so yeah, this must be for the 5 volt because it's the only thing different from the other side. But wow, nice design, I think. So I don't know if it blows or brings air in, but we'll take a look. So there's holes all over the cover, right? Let's take another quick look. See holes everywhere. So I don't know. It could be pulling air in this way and blowing it out everywhere, or it's pulling air through everywhere and sucking it through here. But wow, looks like a nice job to me. Here's the input power, the ground connection coming right down to the board down there for the chassis ground. So yeah, boy, looks nice. I would have to pull the board out to get a good look at these chips, but you can see it looks like there's two sides of this thing maybe. There's crystal here, crystal over there. There's a nice looking chip here, some, you know, a bunch of surface mount parts. There's a surface mount chip right up underneath that rail right there, if you can kind of see it. So yeah, it'd be kind of, I don't know if I want to go to the trouble to do all the work to take this thing out. That looks like some disassembly there. Yeah, that looks like some disassembly to get this board out to give you guys a good look. But yeah, you can see all the chips down in there. So yeah, you can see all the chips down in here. And I think it would take some work to get this board out. So sorry about that. But yeah, just wanted to kind of show you how it looks. And to me, it looks like it has some nice components. A bunch of poly caps, nice through hole resistors, large size, 2 channels. So wow, and that's an impressive transformer. I mean, look at the size of that thing. That thing is like 3 inches tall. And it looks like about 5 inches across. So pretty good size transformer. And the cool thing is there's different voltages. There's wires coming off for this. There's wires coming off for here. I mean, there's a bunch of different secondaries, some small ones. So everything gets powered separately. Everything has its own voltage rails. So yeah, it's not a switching power supply. It's a linear power supply. It's nice and heavy. Okay guys, I put it back together and put a power cord in. You're going to see me power it up for the first time. Pretty cool. Whoop, little chirp. And wow, I guess it's programmed to come up 5.1 volts on both. I heard the fan turn on for a moment and then it turned off. Alright guys, so let's check this out. I think what you do is you push this down and see the decimal. It's kind of hard to see. That's one thing about it. These are not bright at all. The voltage, it's pretty darn dim actually. I don't even know if you can see it in the camera. Wow, that's kind of crazy, I guess. I mean, in person I can see it a lot easier, but maybe you can see it now. But wow, the red's real bright in the camera. This is faint. It's not very dark at all. I wonder if there's an adjustment. I'll look in the manual for that. But what you do is you push this and see it highlights the digit you can adjust, and then it stops flashing if I don't hit anything. See, it rests, but if I hit it and then I can adjust it while it's flashing, hit it again, it changes for that one, and I go to 31 volts, and you can hear the relays clicking in the back, right? See, I can adjust that. And okay, 2103, well, it's only showing 21 on this meter, but okay, let's go to 2108. Okay, 2108, and it says 2105 on the meter here, the testo. So, but I mean, still, for that many places of accuracy for a bench supply, for low-cost bench supply, that's pretty good, I think. But yeah, this, you know, I mean, like I say, to the eye here on the bench, I can see it much better. And when I block it like that, you can probably see it better too. But otherwise, the camera kind of dims out when the camera auto adjusts for the brightness. But yeah, I mean, you can see the green scale. I don't know why they didn't make it red like the current. Maybe to make it obvious when you're looking up close. But I think they should have all been red. I think that would have been better. But that, I mean, like I say, at the bench here you can read it fine. But it is kind of interesting. Here, let's change. I'm going to go to this digit. And we're going to put 2146. And from here, 2143, 44. So, yeah, it's, you know what? That's not too bad, I don't think. Alright, guys, let me show you the program stages, okay? I'm going to try to cover this so you can see these dim displays. We're in parallel mode, so we just have the voltage and current lit up. Now if I hold this button down, the parallel series button, then we have this. So now what this is power on start, and it says on. It's flashing, so we could turn it off. So it's the outer two knobs that control things. This one's to select what we want, and so if you're testing and you set this up for a certain current, over voltage, whatever limits, then you want it to come back up in that stage, then leave that on, and it'll when you power it up, it'll come set up as you left it last time, okay? So we're going to leave that alone. Then the next one's power up. So what this one is, it's in off. So when you turn on the power, these outputs are off until you turn them on with these two buttons, okay? So that's what I want. Otherwise, we could turn it on, but I want it off. Okay, then there's the beeper. If you want to turn it off, you can. And channel 1, lower limit. So you can set the lower limit for current and voltage. So what if you don't want to drop below, say, 3.3? So you can set these things up so that you stay within a lower limit. That's kind of interesting. And then you have a high limit. So right now it's maxed out at 5 amps per channel, 31 volts per channel. Well, that was channel 1. You can do these independently, which is really cool. Channel 2 lower limit, channel 2 higher limit. So that's pretty awesome, I think. Now, I don't have the communications port back, but what it makes me wonder, since it's programmed in here, is if I could add a connector and a cable in the back and talk to this thing. Here's the baud rate, and here's the communication script. Here, let's just see what you can do. D-bus or SCP. So, okay, I guess you got two different buses. Okay, and then see what's the options here. So this is just all options that I don't even really care about, since I don't have the communication ports, and you know, I normally don't hook up power supplies, but if you're, you know, with communication ports, but if you're doing an auto test lab, that's nice to have that kind of stuff. But yeah, pretty cool. Then I think you just push this button. Yep, there you go. You're back in business. So we'll go back to series. So we got our, well, sorry, this is independent. Lights off, so that's independent. Now we're in series mode. It says SC, and we have in series, we're going to have 21.5 volts that we can adjust and 1.9 amps. So yeah, there we go. Pretty cool. There's a parallel mode again, and there's independent mode where you can independently, you know, control both. Okay. All right, guys, we'll do a little test right here. I got my meter here tied to this output, but basically we can see the voltages here, and we can already tell that these meters are pretty darn accurate. So what I've got is a 4 ohm load here, 8 ohm load here. So I've got this set for 24 volts. Okay, guys, I'm gonna zoom in here so you can actually see the display. Okay, so I'll go ahead and turn on this output right here, and you know, 8 ohms, 24 volts is about 3 amps. Now it's not exactly 8 ohms, that's why it's off a little bit, but pretty darn close. And it's saying 24 volts, and this guy is actually saying 23.97, so it's off just a touch. Okay, now this one, 4 ohms, and I got 31 volts. So let's turn on its output, and you see the little lights here, the CC, that's constant current. So it's providing 5 amps, 5.1 amps, the max it can. But yeah, it's the voltage dropped down to 19 volts because it can't supply enough current into 4 ohms. So it can only, you know, say 20 volts into 4 ohms. Oh, I just heard the fans kick on. Alright, guys, I can feel the air back here, and it's sucking air and blowing it out these holes. So it's coming out everywhere, but it's blowing it across the heat sink, sucking it through the heat sink, so it's getting nice cool air from the back, bringing it through the heat sink, and then blowing it all around inside the box so it goes everywhere. Alright, so let me cover up this display so you can see it. I'm going to zoom in on the display again. Alright, so we zoomed in on the display again, and I'm going to back off the voltage here. So push this, and we'll go to the 3 column, we'll drop it down to 11 volts. And 11 volts and 4 ohms is about 2.8 amps. Alright, so there we go. So now I could drop the voltage down a little bit more. What if I drop it down to 4 volts? We should get about 1 amp, right? And there we go. About 1 amp. Alright, so that's the independent mode. What if I go to parallel while the outputs are turned on? Let's see what happens. Coming over here to hit the button. Okay, it went in series first, but it turns off the outputs. That's good that it does that, because you wouldn't want to accidentally hit that and have a problem. So you can see the voltage over here. So it's in series. Alright, the one interesting thing is again, it's saving the last time I was in the mode. So last time I was in the series, I had 2055, so it saved that. So let's go ahead and drop that down to 10 volts. I just want to try something. 1, and then I'll go back to this digit. Let's go to 10 volts. Well, actually, you know what? I want to go to 20. Okay, there we go. There's 20 volts. Okay, so what I'll do is turn this on. Look at that, we have 2 amps, because 20 volts, that's interesting. So we got a combination of things going on. The meter over here, I've got it plugged into output 1, and it's saying 9.97, but we have 7.4 volts on this one because we have 4 ohms there. So that's interesting. I've got 4 ohms on one and 8 ohms on the other. So that's not really how you use series mode. Okay, what you do in series mode is you go across from here to here. Okay, so and then it gives you the voltage from all the way across like that. Okay, so see there's, and it's saying 17.4 because the 4 ohms is pulling down one side of it. Okay, and right here, if you can see that, it says 17.4. So yeah, right down here 17.43. My meter says 17.4. So yeah, it's pretty darn close. So that's how, you know, series, so you put your load across the whole thing. That's if you want a higher voltage, like up to 60 volts. Okay, I'm going to try to let you see both displays because I'm going to hit the button again and it'll put it in parallel. Let's see what happens. Alright guys, so here, let me cover this up here. Let's set, whoops. Okay, we're in parallel mode. Let's max out. Okay, 10.2 amps is maxed. And we have 26 volts. Let's go ahead and turn it on. Whoa. Okay, 26 volts, and we're putting about 9.8 amps. So, yeah, that's 8 ohms. So there we go. Covered up like this. This says 25.99. My meter's 25.97. So pretty darn close. So here we'll adjust the voltage down. Alright guys, one thing I noticed, I had to disconnect this. I thought when it goes parallel, it puts it all over here. But at the same time, if you do have something connected over here, they're still connected. But it does connect them both here, so you can get the parallel current out of here. So here, let's go ahead and crank this up. Okay, there's 31. We can pull about 3.8 amps into 4 ohms. Wow, that resistor's still kind of hot. So yeah, I gotta say, so far, now it's a linear power supply, so I expect it to be really quiet. I like to do some step load tests and things like that. You know, I think I like to compare it to this guy back here because it's the closest thing to it. And yeah, what do you guys think? Let me do another video where I do some exercising and really run this through some paces. But right now, this seems to be a nice supply. Looks like it's really well built. That toroid transformer, nice to have the manual, right? But I looked through the manual, no adjustments for the display. That's the one down, you know, side I'd say to this is these right here, you just can't see. And even sitting here, they're dim. I mean, they're not very bright. The red ones are perfect, not too bright. They're just perfect, I think. But these two, too dim. I'm wondering, I'm going to email them and ask them if there's a way to, you know, even manually adjust them from the inside. Maybe there is, but it's too bad in the menu that there wasn't a way to adjust the contrast, the brightness level of each one, because, you know, maybe the red ones are bright and maybe somebody would like to dial them down a little bit. I don't think they're bright. They're not as bright as some of the other displays I have, but that's the only knock I'd give them so far. Everything else looks very solid. Like the terminals, they're spaced correctly, and I like the layout. I like everything about this thing except for these. So for a triple output supply, it's a nice one. The price on this thing is, I hate to say it because you never know what it is in your country, but on Amazon today, I think, and also there's a coupon code, so use that coupon code down below and you'll get a discount, okay? That was really nice. They offered me that coupon code. They sent this to me. Thanks, Matrix. 2 thumbs up to you guys for sending this out to me and providing the discount code. I believe you can, I think it's like 20% off, I think. Don't hold me to that. But I believe this thing's around $220 with the discount. Not positive. That is a really good deal, I believe. I think that's a great deal for 5 amp, 5 amp, and 5 amp. So you get max 5 amp on each one versus something like this. It cost me about, I want to say I paid about this much for this guy used on eBay. You can check it out and see what you See the GWN stack? That's the GPC 3030D, okay? And this is the Matrix MPS-3005H. Now, between the two, I would definitely take this one, even if it was only 3 amps. I just like the way it operates. I like the on-off button. That's a big deal. I just really wish it was on this. There's so many times that I don't want to change the settings. I just want to turn them on and off. And also, that's a way where you can do step input voltage for something you're testing, like a power supply. You can step the input voltage on off, and see what, see how it behaves. So really like that function. This Tektronix that GW made for Tektronix has those features. It doesn't have the diodes. I like the dial encoders, so it kind of gives you that analog feel, but it's really kind of a digital thing. You can hear all the relays clicking because as you turn these on and off, it clicks on relays to turn them on and off, so you're getting a relay through different ranges. I want to put it on a scope and load it and change the voltage, and when those relays click, I want to see if it affects output voltage. So that's the test to do. What do you guys think? 2 thumbs up to my patrons. Really appreciate you guys. Hey, and I really appreciate you guys who have hit the thank you button down below. It's down next to the free like button. You can always hit a free like button. That helps the channel a lot. It's a free way to help the channel. But if you do want to, buy a cup of coffee for me or something like that, there's a thank you button. And you guys that have done that, thanks a lot. That's a big thanks. I like this power supply. Jeez, do I have room? I don't know. What do you guys think? Maybe it's time to get rid of this one, right? Okay. All right, guys. Well, hey, thanks for watching. I kind of want to test side by side with this guy and this guy just to see, if this guy can replace that one. Totally. Because it has the range and it has the features that one doesn't have. So maybe the GWN tech will be up for sale. All right. Thanks for watching, guys. We'll see you next time.